Have you ever tried to imagine what lies beyond everything? I mean, really tried to picture what exists outside the furthest reaches of reality itself? It's one of those thoughts that can make your brain feel like it's short-circuiting, wrestling with a concept so fundamentally bizarre that it challenges every assumption you've ever made about how the world works. Tonight, we're diving headfirst into what might be the most mind-bending question in all of science. If the universe is constantly expanding, growing larger every second, what exactly is it expanding into? What's out there in that space it's moving into? Before we go any further, let me tell you why this question will absolutely mess with your head in the best possible way. This isn't just some abstract puzzle for physicists to argue about in lecture halls. The answer we're about to explore together will fundamentally change how you think about space, time, and your place in the cosmic order. It's going to challenge every intuitive understanding you have about how expansion works. I'm genuinely curious where you're joining me from tonight. Drop your location in the comments below. There's something beautiful about people all over the world contemplating these cosmic mysteries together. Also, if you find these explorations into the deepest questions of existence as fascinating as I do, I'd be incredibly grateful if you'd hit that subscribe button and give this video a thumbs up. The visuals are here for you, but feel free to just listen if you prefer. Let's begin this journey to the edge of understanding itself. Now, picture this scenario. You're standing in your backyard on a perfectly clear night, staring up at thousands of stars scattered across the darkness like diamonds on black velvet. Those points of light seem so permanent, so unchanging, like they've been frozen in place since the beginning of time. But here's what's actually happening up there, and it's going to blow your mind. Every single one of those distant galaxies is racing away from us at speeds that would make your head spin. We're talking about velocities of thousands of miles per second. But here's the kicker that makes this even more bizarre. They're not flying through space like rockets blasting away from Earth. Space itself is stretching, growing, inflating like some cosmic balloon that's been expanding for nearly 14 billion years. Think about that for a second. Space itself is getting bigger. Not stuff moving through space, but the actual fabric of space expanding like dough rising in an oven. And that leads us directly into the question that's going to keep us busy tonight. When we say the universe is expanding, what does that actually mean? And more importantly, if it's getting bigger, what is it getting bigger into? Your brain probably wants to picture this like a balloon being inflated in a room. The balloon gets larger by pushing into the air around it, taking up more space in the room. So naturally, you'd think the universe must be expanding into some kind of cosmic room, some vast emptiness that was already there waiting to be filled. But what if I told you that this perfectly reasonable assumption might be completely wrong? What if the universe isn't expanding into anything at all? What if the very question itself is based on a misunderstanding so fundamental that asking it is like asking what flavor the color blue tastes like? This is where things start to get genuinely weird, and I promise you, we're just getting started. To understand why this question is so tricky, we need to go back to a discovery that completely revolutionized how we think about the cosmos. It happened less than a century ago, which means your great-grandparents lived in a time when humanity had a totally different picture of the universe. For most of human history, we assumed the cosmos was static and eternal. The stars were fixed points of light that had always been there and always would be. Even Albert Einstein, when he first developed his theory of general relativity, was so convinced the universe was unchanging that he actually added a mathematical fudge factor to his equations to keep it from expanding or contracting. Then came Edwin Hubble in the 1920s. Using the most powerful telescope of his era, Hubble made observations that shattered our comfortable assumptions about a static cosmos. He discovered that distant galaxies weren't just sitting there peacefully, they were moving. And not just moving randomly, but moving in a very specific, very strange pattern. The farther away a galaxy was from us, the faster it was racing away. This wasn't what anyone expected to find. At first glance, this might make you think we're sitting at the center of some massive cosmic explosion, with everything flying away from our privileged position in the universe. But that's not what's happening at all. Here's a way to picture what Hubble discovered. Imagine you're an ant living on the surface of a balloon that someone is slowly inflating. As the balloon grows, every other ant on the surface would appear to be moving away from you. But you're not at the center of anything special. The exact same thing would be true for every single ant on the balloon. Each one would see all the others moving away from them. This is precisely what's happening in our universe. Except instead of ants on a two-dimensional balloon surface, we're dealing with galaxies in three-dimensional space. The space between everything is stretching, carrying galaxies along with it, like raisins in rising bread dough. Now here's where your brain is going to start rebelling against what physics is telling us. If space is expanding, every fiber of your being screams that it must be expanding into something. After all, in every example of expansion you've ever witnessed in your life, things expand by pushing into something else that was already there. A balloon expands by pushing into the air around it. A city expands by growing into the countryside that surrounds it. Your lungs expand by drawing air from the atmosphere into your body. This pattern is so universal in human experience that assuming it applies to the universe seems perfectly reasonable. But the expansion of the universe is unlike any expansion we encounter in our daily lives. It's not objects moving through space, it's space itself changing, growing, creating more of itself as time passes. This is where we hit the first major conceptual hurdle. When space expands, it's not expanding into some pre-existing void or empty arena. There is no arena, there is no outside, there is no surrounding emptiness waiting to be filled. The universe isn't expanding into anything because there is no anything for it to expand into. Let me pause here because I can practically hear your brain grinding its gears, trying to process this idea. How can something expand without expanding into something else? It seems to violate every experience you've ever had with expansion. But remember, the expansion of the universe operates according to principles that are completely foreign to our everyday experience. We're trying to understand something that transcends the normal categories our minds use to make sense of the world. Think of it this way. Imagine you're a character living in a two-dimensional world, like a drawing on a piece of paper. Your entire reality consists of moving around on that flat surface. Now someone starts stretching the paper, making it bigger in all directions. From your perspective as a two-dimensional being, your world is definitely expanding. Distances between cities are growing. It takes longer to travel from one place to another. But the paper isn't expanding into your two-dimensional world. It's expanding into a third dimension that you can't perceive or access. But here's the crucial difference with our universe. There's no evidence for any higher dimensional space that we're expanding into. The universe appears to be all there is. When space expands, it's not expanding into some pre-existing void. It's creating space as it goes. This leads us to one of the most profound questions in all of science. What does it mean to say that something doesn't exist? When we say there's nothing outside the universe, what exactly do we mean by nothing? The nothing that lies beyond the universe isn't empty space. Empty space is still something. It has properties. It can curve. It can contain energy. It can expand. The nothing beyond the universe is the absence of space itself. It's not a place you could travel to because there's no there. It's not empty because emptiness implies a container that happens to be vacant. This nothing is more radical than that. It's the absence of the very possibility of containment. This is where language starts to completely break down. We're trying to use words that evolved to describe our everyday experience to discuss concepts that transcend everyday experience entirely. It's like trying to describe the color red to someone who was born blind, or explaining music to someone who has never heard a sound. But the strangeness doesn't stop there. If the universe is truly all there is, if there's nothing beyond it in any meaningful sense, then what determines its shape? What decides how it expands? What governs its behavior? The answer takes us into even more mind-bending territory. The universe doesn't have to be infinite to avoid the problem of expanding into something. It could be finite, but unbounded. Think again about that ant on the balloon. The surface of the balloon has a finite area, but it has no edge. The ant could walk in any direction forever and never reach a boundary. The surface curves back on itself in ways the ant can't directly perceive. Our universe might be similar, but in 3 dimensions instead of 2. It could have a finite volume, but no edge anywhere. Travel in any direction long enough, and you might eventually return to where you started, like circumnavigating the globe, but in 3-dimensional space. The universe could be curved in ways we can't directly perceive, wrapped around itself in dimensions beyond our normal experience. This would be a finite universe with no boundaries, no edges, no outside. Alternatively, the universe could be truly infinite, stretching on forever in all directions. In this case, the expansion isn't about the universe getting bigger in some external sense. It's about the distances between things increasing. An infinite universe can still expand because expansion is about the scale of things, not about the total size. Both possibilities avoid the problem of needing something to expand into, but they raise new questions that are just as puzzling. If the universe is infinite, how did it become infinite? If it's finite but curved, what determines its curvature? These questions take us to the very edge of human understanding. We're probing mysteries that might be fundamentally unknowable, not because we lack the intelligence or technology to solve them, but because they involve concepts that transcend the categories through which any conscious mind must think. But there's something beautiful in this mystery. It reminds us that reality is far stranger and more wonderful than our everyday experience suggests. We live in a universe that challenges our assumptions, that forces us to expand our minds just as space itself expands around us. The deeper we dig into this question of what the universe expands into, the more we discover about the fundamental nature of space, time, and existence itself. We're about to explore cutting-edge theories that suggest our universe might be just one bubble in an infinite foam of realities. We'll examine the possibility that the question itself might not have an answer, not because we don't know it, but because the question might be meaningless. The journey ahead is going to stretch your imagination to its absolute limits. We'll encounter ideas so radical they redefine what it means for something to exist. But that's exactly why this exploration matters so much. The more we examine this cosmic puzzle, the more we realize we're dealing with something that operates by rules completely different from anything in our everyday world. And here's where things get truly extraordinary. Right now, as you're sitting there listening to this, space itself is expanding between your eyes and the screen you're watching. The distance between Earth and the Moon is growing. Even the space inside your own body is stretching, though by amounts so incredibly tiny that you could never notice them. Before you start worrying about your atoms drifting apart, let me explain why you're not falling to pieces. The expansion of space is incredibly subtle on small scales. It only becomes noticeable across vast cosmic distances. The electromagnetic forces holding your atoms together, the gravitational pull keeping Earth in orbit around the Sun, these forces are strong enough to completely overpower the expansion of space locally. Picture it like this. Imagine you have a rubber sheet with coins glued to its surface. As you stretch the sheet, the coins themselves don't get bigger because the glue holds them together firmly. But the distances between the coins increase dramatically. That's exactly what's happening in our universe. Galaxies, solar systems, even entire clusters of galaxies are like those coins, held together by their own gravity while the space between them stretches. This reveals something absolutely profound about the nature of space itself. Space isn't just an empty container where things happen to exist. It's dynamic, active, almost alive in a sense. It has properties that can change. It can bend and stretch. It can even ripple when massive objects accelerate through it. These ripples, called gravitational waves, were predicted by Einstein over a century ago, but only detected recently by incredibly sensitive instruments. They're like echoes through the fabric of space itself, created when black holes collide or neutron stars spiral into each other. But if space is this dynamic, shape-shifting fabric of reality, what exactly is it made of? This question has puzzled physicists for generations, and the answer might surprise you. In our everyday world, we can always ask what something is made of. Water is made of molecules. Molecules are made of atoms. Atoms are made of even smaller particles. But what is space made of? The answer might be that this question doesn't make sense. Space might be fundamental, irreducible, not made of anything more basic. It simply is. Asking what space is made of might be like asking what the number 7 is constructed from, or what the concept of justice is built out of. Some theories suggest that space and time emerge from more fundamental quantum processes, that what we think of as the smooth fabric of space-time is actually made up of tiny discrete units at the smallest possible scales. These theories propose that if you could zoom in far enough, space would reveal itself to be grainy, pixelated, like a photograph examined under extreme magnification. But even if space is made of something more fundamental, this doesn't solve our original mystery. It just pushes the question back one level. If space is expanding and space is made of something more basic, then what is that more basic stuff expanding into? This is where we encounter what philosophers call an infinite regress. Every answer raises a new question. Every explanation requires a deeper explanation. At some point, we might have to accept that there are aspects of reality that simply are, without needing or having a deeper explanation. Here's another possibility that might completely flip your understanding upside down. What if our entire understanding of expansion is backwards? What if the universe isn't expanding into anything? Because expansion itself is an illusion. Some physicists have proposed that what we interpret as the expansion of space might actually be the result of time itself changing. Perhaps the fundamental constants of physics are slowly evolving over cosmic time, making atoms smaller, rulers shorter, and clocks slower. From our perspective, trapped within this changing system, everything would appear to be moving away from us as space expanded. But from some external viewpoint, if such a thing could exist, the universe might be completely static, while the very nature of measurement changes. This idea sounds absolutely crazy, but it's actually consistent with all our observations. The redshift of distant galaxies, the cosmic microwave background radiation, even the abundance of light elements in the universe could all be explained by changing physics rather than expanding space. It's a minority view among cosmologists, but it demonstrates just how strange and counterintuitive the true nature of reality might be. The fact that such radically different explanations can account for the same observation shows us how much we still don't understand about the cosmos. But there's an even more mind-bending possibility that emerges from quantum mechanics. That bizarre theory that governs the behavior of the smallest particles. In quantum mechanics, particles don't have definite positions until they're observed. They exist in a fuzzy state of probability, potentially everywhere at once, until measurement forces them to choose a specific location. What if space itself has quantum properties? What if the expansion of the universe is somehow tied to the quantum nature of reality? Some theories suggest that space might be constantly creating itself through quantum processes. Virtual particles pop into existence from the quantum vacuum, briefly borrow energy from the future, and then disappear before anyone notices. But what if sometimes they don't disappear? What if some of these quantum fluctuations become permanent, adding new bits of space to the universe? In this picture, the universe doesn't expand into pre-existing space. It creates new space as it goes, pulling it from the quantum foam that underlies all of reality. The expansion isn't motion through space, but the birth of space itself, moment by moment, from the fundamental uncertainty that quantum mechanics tells us pervades everything. This connects to one of the most successful theories in modern cosmology called cosmic inflation. In the first tiny fraction of a second after the Big Bang, the universe underwent a period of exponentially rapid expansion. Space itself inflated faster than the speed of light, growing from something smaller than a proton to something larger than a grapefruit in less time than it takes light to cross that proton. During inflation, space wasn't expanding into anything. It was creating itself through quantum processes so rapid and so extreme that they defy imagination. The energy driving this expansion came from quantum fields that fill all of space, fields that we normally think of as empty vacuum, but which actually seethe with hidden energy. Inflation explains many puzzling features of our universe. It explains why the cosmic microwave background radiation is so uniform across the sky, why space appears to be geometrically flat, and why we don't observe certain exotic particles that earlier theories predicted should be abundant. But it also suggests something remarkable about the nature of space itself. If inflation can create space from nothing, if quantum processes can generate new regions of space-time, then perhaps our entire universe is just one bubble in an infinite foam of expanding regions. Perhaps inflation never really ended, but continues eternally in some regions, while ending in others like ours. In this picture, our Big Bang wasn't the beginning of everything, but just the moment when inflation ended in our particular patch of a much larger multiverse. This eternal inflation scenario suggests that there might be countless other universes beyond our own, each with its own laws of physics, its own constants of nature, its own history. Some might be similar to ours, while others might be so alien that we lack the concepts to describe them, and all of them would be expanding not into some pre-existing space, but creating their own space as they grow. Each universe would be self-contained, generating its own arena for existence, rather than occupying territory in some larger cosmic real estate. But this raises a new version of our original question. If there are multiple universes, multiple expanding regions of space-time, what separates them? What lies in the gaps between universes? The answer, once again, might be nothing. Not empty space, but the complete absence of space, time, and physical law. A kind of non-existence so radical that calling it nothing almost gives it too much credit. This is where we start to realize that our original question might be based on a fundamental misunderstanding. We asked what the universe is expanding into because we assumed that expansion must be into something. But perhaps expansion is more fundamental than that. Perhaps it's not that space expands into something else, but that expansion is what creates the very possibility of something else existing at all. This shifts our entire perspective on reality. Instead of thinking of space as a container that holds things, we might need to think of it as a process, a continuous becoming, rather than a static being. The universe isn't a place where events happen. It's the happening itself, the ongoing process of space and time creating themselves moment by moment. In this view, asking what the universe expands into is like asking what happens before the beginning of time, or what exists outside of existence itself. These aren't questions that lack answers. They're questions that dissolve under examination, revealing themselves to be based on assumptions that don't match the deeper reality of how things actually work. But even if our question turns out to be meaningless, the journey of exploring it has revealed something profound about the nature of reality and our place within it. But we've discovered that space is not the passive stage where cosmic drama unfolds, but an active participant in that drama. We've learned that expansion is not motion through space, but the creation of space itself, and we've glimpsed the possibility that our universe might be just one bubble in an infinite ocean of reality. These revelations force us to confront something even more unsettling about our cosmic situation. If space itself is expanding, if it's creating more of itself as time unfolds, then what does this mean for the concept of infinity? Can something that's growing ever be truly infinite? And if the universe is already infinite, how can it expand at all? This paradox has kept cosmologists awake at night for decades. Picture an infinite line of numbers stretching endlessly in both directions. Now imagine that line expanding, with more space appearing between each number. The line was infinite before the expansion and remains infinite afterward. But the distances between numbers have grown. This is how an infinite universe can expand without becoming more infinite than it already was. But here's what makes this even more mind-bending. If the universe is infinite, then there are infinite copies of you scattered throughout space. Not just similar people, but exact duplicates living identical lives, making identical choices, having identical thoughts at this very moment. The mathematics of infinity demands it. In an infinite universe, with finite possible arrangements of matter, every possible configuration must occur infinitely many times. Somewhere out there, infinite versions of you are pondering this same question about cosmic expansion. Some are sitting in rooms identical to yours, while others are in rooms where just one atom is positioned differently. Still others live in worlds where history unfolded along completely different paths. There are versions of you who became astronauts, versions who never learned to read, versions living in societies we can't imagine. This isn't science fiction or philosophical speculation. If the universe is truly infinite, this is a mathematical necessity. And it reveals something profound about the nature of existence itself. In an infinite cosmos, everything that can happen does happen, somewhere, somewhen. Every story that could be told is being lived out in infinite variations across the vast expanse of space. But let's step back from these mind-melting implications and consider what modern physics tells us about the actual shape and structure of our expanding universe. When Einstein developed his theory of general relativity, he discovered something revolutionary. Space isn't flat like a tabletop. It can curve, bend, and warp in response to matter and energy. Massive objects like stars and black holes create dips and valleys in the fabric of space-time, and this curvature is what we experience as gravity. The universe as a whole has a shape determined by its total energy content. Think of it like this. If there's more than a certain critical amount of matter and energy, space curves back on itself like the surface of a sphere. In such a universe, travel far enough in any direction, and you'll eventually return to your starting point, like circumnavigating the globe, but in 3 dimensions. If there's less than the critical amount, space curves outward like a saddle, extending infinitely in all directions. And if there's exactly the critical amount, space is perfectly flat like an infinite sheet of paper. Remarkably, our observations suggest that we live in this third type of universe. Space appears to be geometrically flat on the largest scales we can measure. This flatness is actually quite mysterious because it requires the total energy density of the universe to be balanced at exactly the critical value with extraordinary precision. It's like balancing a pencil on its point for 14 billion years. This geometric flatness has profound implications for what the universe is expanding into. In a flat, infinite universe, there's no center and no edge. Every point looks the same as every other point on the largest scales. The expansion isn't happening from some central location outward. It's happening everywhere, simultaneously. Space is stretching uniformly, creating more room between distant objects while leaving the overall geometry unchanged. Imagine you're painting dots on a deflated balloon, then inflating it. From the perspective of any dot, all the other dots appear to be moving away, but there's no single point that's the center of the expansion. The expansion is happening everywhere on the balloon's surface at once. Now extend this analogy to 3 dimensions and remove the need for any external space to expand into. That's what's happening to our universe. But here's where things get really strange. The expansion of space affects light in ways that challenge our understanding of distance and time. When light travels from a distant galaxy to our telescopes, it's not just crossing space. It's traveling through space that's expanding as the light moves through it. This stretches the wavelength of the light, making it redder and redder as the universe grows. This means that the most distant galaxies we can see aren't where they appear to be. By the time their light reaches us, they've been carried much farther away by the expansion of space. Some of the galaxies whose light we're seeing today are now so far away that light leaving them today will never reach us. The expansion of space is carrying them away faster than light can travel through that expanding space. This creates what cosmologists call the cosmic horizon. There's a boundary in space beyond which we can never receive information, not because there's nothing there, but because the expansion of space prevents any signal from reaching us. It's like trying to swim upstream against a current that's flowing faster than you can swim. You make progress through the water, but you still get carried backward relative to the shore. The existence of this horizon raises profound questions about the nature of reality and knowledge. If there are regions of space from which no information can ever reach us, do those regions really exist? Is reality limited to what can, in principle, be observed? Or does the universe extend infinitely beyond what we can ever hope to see? Some physicists argue that unobservable regions of the universe don't meaningfully exist from our perspective. If something can never affect us in any way, if no information about it can ever reach us, then it might as well not exist at all. This view suggests that reality is fundamentally observer-dependent, limited by the cosmic horizons that surround each observer. Others maintain that the universe extends far beyond what any observer can see. In this view, our cosmic horizon is just a limitation of our perspective, not a boundary of existence itself. The universe is what it is, regardless of whether we can observe all of it. Countless galaxies exist beyond our horizon, evolving and changing in ways we'll never know about. Both perspectives lead to unsettling conclusions about the nature of existence and our place within it. If reality is limited by observation, then consciousness plays a fundamental role in determining what exists. If reality extends infinitely beyond observation, then we're isolated islands of awareness in an ocean of unknowable existence. These questions become even more complex when we consider the possibility that our universe might not be alone. The same quantum processes that drove cosmic inflation in our universe might be creating new universes elsewhere, each with its own expanding space, its own laws of physics, its own cosmic horizons. In this multiverse scenario, our Big Bang was just one bubble nucleating in an eternal sea of quantum foam. If this picture is correct, then asking what our universe is expanding into might be like asking what our galaxy is moving through. Just as our galaxy moves through the larger universe, our universe might exist within some larger structure that we can't directly observe. But unlike the space our galaxy moves through, this larger structure wouldn't be made of space as we understand it. It would be something more fundamental, perhaps the quantum foam from which space itself emerges. This possibility opens up even stranger questions. If multiple universes exist within some larger structure, do they ever interact? Could two expanding universes collide? What would happen at the boundary between different regions of space-time with different physical laws? These questions push us to the very limits of theoretical physics, into realms where mathematics becomes our only guide through landscapes of possibility that defy imagination. Some theories suggest that universe collisions might be detectable. They could leave subtle patterns in the cosmic microwave background radiation, like dents in the wall of space itself. Scientists are actively searching for these signatures, hoping to find evidence that our universe has bumped into others in the distant past. So far, no definitive signals have been found, but the search continues. The possibility of a multiverse also raises questions about the uniqueness of our physical laws. We're used to thinking of constants like the speed of light, the strength of gravity, and the mass of electrons as universal features of reality. But if multiple universes exist, these constants might vary from one universe to another. Our universe might just happen to have the particular combination of values that allows stars, planets, and life to exist. This idea, known as the anthropic principle, suggests that we observe the laws of physics we do because we couldn't exist in a universe with different laws. It's a selection effect. We find ourselves in a life-friendly universe not because all universes are life-friendly, but because we couldn't find ourselves anywhere else. In universes where stars never form, or where atoms can't exist, there's no one around to observe the hostile physics. This anthropic reasoning is controversial among physicists. Some see it as a cop-out, a way of avoiding the hard work of finding deeper explanations for why our universe has the properties it does. Others argue that it might be the only explanation possible for certain features of our cosmos. If the multiverse is real, if countless universes exist with every possible combination of physical laws, then anthropic reasoning might be unavoidable. But whether our universe is unique or one of countless others, whether it's expanding into something or creating space as it grows, we're still left with the fundamental mystery of existence itself. Why is there anything at all rather than nothing? Why do quantum fields exist? Why do the laws of physics take the forms they do? These questions might be forever beyond our ability to answer. Not because we lack the intelligence or technology, but because they might not have answers in any conventional sense. Perhaps existence is simply a brute fact requiring no deeper explanation. Perhaps the question, why something rather than nothing, is like asking why the number 7 is odd, or why triangles have 3 sides. Some features of reality might be so fundamental that asking why they exist is meaningless. Or perhaps we're approaching these questions from the wrong angle entirely. Maybe existence and non-existence aren't opposite states, but different perspectives on the same underlying reality. Maybe what we call nothing is actually teeming with potential, pregnant with all possible universes, and what we call something is just one way that potential manifests itself. These possibilities push us toward a radical reconceptualization of reality itself. Instead of thinking of existence as something that needs explanation, we might need to think of it as the very ground from which all explanations emerge. Instead of asking what the universe is expanding into, we might need to ask what expansion itself tells us about the nature of being. The journey we've taken through these cosmic mysteries reveals something profound about the relationship between human curiosity and the deepest questions of existence. We began with what seemed like a simple question about space and expansion. But we've discovered that this question opens onto fundamental mysteries about the nature of reality, consciousness, and knowledge itself. We've been wrestling with concepts that push language to its breaking point, ideas that challenge every assumption we make about how things should work. But perhaps that's exactly as it should be. Perhaps the deepest truths about reality are the ones that make us uncomfortable, that force us to abandon our comfortable assumptions and venture into territories where our everyday experience provides no guidance. The universe doesn't owe us explanations that fit neatly into categories our minds find comfortable. It simply is what it is, operating according to principles that might forever remain partially mysterious to creatures like us. embedded within the very system we're trying to understand from the outside. Yet in wrestling with these impossible questions, in pushing our understanding to its limits, we touch something profound about what it means to be conscious beings in a cosmos that challenges comprehension. We are arrangements of atoms that have somehow become complex enough to contemplate the very processes that brought us into existence. That alone might be more remarkable than any answer we could discover about what lies beyond the edge of everything. But here's where our cosmic journey takes a turn that's going to make everything we've discussed so far seem almost simple by comparison. We need to talk about what happens when we try to measure the universe's expansion, because the very act of measurement reveals something so bizarre about the nature of space and time that it challenges our most basic assumptions about reality itself. Right now, astronomers are pointing their most powerful telescopes into the deepest reaches of space, capturing light that has been traveling toward us for billions of years. When they analyze this ancient starlight, they're not just seeing distant galaxies, they're literally looking backward through time, watching the universe as it existed when it was younger, smaller, and fundamentally different from what we observe today. But here's the mind-bending part. The farther out we look, the faster everything appears to be moving away from us. And I don't just mean a little faster. We're talking about galaxies at the edge of the observable universe, racing away at speeds approaching the velocity of light itself. Some regions are receding so rapidly that they're crossing what physicists call the Hubble sphere, a boundary beyond which objects move away from us faster than light can travel through the expanding space between us. Now you might be thinking, wait a minute, didn't Einstein prove that nothing can travel faster than light? And you'd be absolutely right. But here's the crucial distinction that makes this whole situation even more surreal. These galaxies aren't moving through space at faster than light speeds. Space itself is carrying them away at these incredible velocities. It's like standing on one of those moving walkways at an airport, except the walkway is accelerating continuously, and the faster it moves, the faster it accelerates. You're not walking any faster than normal, but the walkway beneath your feet is carrying you at ever-increasing speeds. This creates one of the most haunting implications of cosmic expansion. There are galaxies out there whose light is reaching us right now, allowing us to see them in all their ancient glory. But if we try to send a message to them today, traveling at the speed of light, that message would never arrive. The expansion of space would carry these galaxies away faster than our signal could catch up to them. Think about what this means. There are entire civilizations out there, potentially billions of them, that we can observe but could never communicate with. They exist in what cosmologists call our past light cone, but outside our future light cone. We can see their history, but we can never be part of their future. This isn't just theoretical isolation. It's a fundamental feature of living in an expanding universe. There are regions of space that are causally disconnected from us, not because they're physically unreachable, but because the geometry of space-time itself prevents any form of interaction. But the strangeness deepens when we consider what this expansion means for the concept of distance itself. When we say a galaxy is 10 billion light years away, what exactly do we mean? The light we're seeing from that galaxy left it 10 billion years ago, but where is the galaxy now? The answer is both simple and completely mind-boggling. That galaxy is now much farther away than 10 billion light years because space has been expanding the entire time its light was traveling toward us. By the time we see the light, the galaxy that emitted it might be 15 or 20 billion light years away. carried to that distance by the expansion of space itself. This means we're never actually seeing the universe as it is now. We're always seeing it as it was. The deeper we look into space, the further back in time we're looking. The most distant galaxies we can observe show us the universe when it was just a few 100 million years old, barely out of its cosmic infancy. But here's where it gets truly weird. Some of those ancient galaxies we're observing are now so far away that they exist beyond our cosmic horizon. Their current location is in a region of space from which no information can ever reach us. We can see their past, but their present is forever hidden from us. This creates a strange kind of cosmic nostalgia. We're surrounded by light from objects that no longer exist in any form we could ever interact with. The universe we observe is like a vast museum of its own history, filled with exhibits from eras we can study but never revisit. The expansion also affects how we think about the age of the universe itself. We say the cosmos is about 13.8 billion years old. But what does that actually mean in a universe where time and space are expanding together? Here's something that might blow your mind. The cosmic microwave background radiation, that faint afterglow of the Big Bang that fills all of space, is coming to us from every direction. But the matter that emitted this radiation is no longer where it appears to be in the sky. Due to expansion, that matter is now part of galaxies located far beyond our observable horizon. We're seeing the baby picture of matter that has since grown up and moved to neighborhoods we'll never be able to visit. It's like receiving a childhood photograph from someone who now lives on a different planet that you can never reach. This expansion of the observable universe creates what might be the strangest property of cosmic space. The boundary of what we can see isn't fixed, it's constantly growing. Every second, light from more distant regions of the universe crosses into our observable sphere. We're continuously gaining new territories to explore, new volumes of space whose existence we can finally confirm. But simultaneously, we're losing objects that were once observable as they get carried beyond our cosmic horizon by accelerating expansion. The universe we can see is both growing and shrinking at the same time, gaining new regions in some directions while losing others to the accelerating expansion driven by dark energy. This dark energy, which makes up about 68% of everything in the universe, remains one of the deepest mysteries in physics. We know it's there because we can measure its effects on cosmic expansion, but we have almost no idea what it actually is. It behaves like a kind of anti-gravity, pushing space apart rather than pulling it together. But here's what makes dark energy especially relevant to our question about expansion. Unlike normal matter and energy, which become more dilute as space expands, dark energy maintains a constant density. As the universe grows, the total amount of dark energy increases. It's as if space itself has an inherent tendency to create more space. This leads to a truly mind-bending possibility. If dark energy continues to dominate the universe's expansion, if it keeps pushing space apart with ever-increasing strength, then the ultimate fate of our cosmos becomes almost unimaginably strange. The galaxies will eventually be carried so far apart that they disappear beyond each other's horizons. Stars will burn out in isolation, unable to see or interact with anything beyond their immediate neighborhoods. The universe will become a collection of island universes, each containing a single galaxy or cluster, surrounded by empty, expanding space. But the acceleration might not stop there. Some scenarios suggest that dark energy could become so powerful that it overcomes not just gravity, but all the fundamental forces that hold matter together. Space could expand so rapidly that it literally tears apart the fabric of reality itself. First, galaxy clusters would lose their gravitational grip. Then, individual galaxies would be ripped apart. Solar systems would be shredded. Planets would be torn from their orbits. Eventually, even atoms themselves might be pulled apart by the accelerating expansion of space. This scenario, called the Big Rip, would represent the ultimate triumph of expansion over structure. The universe would literally tear itself apart, destroying every form of organization that billions of years of cosmic evolution had created. In such a universe, asking what space expands into becomes almost meaningless. There would be no persistent structure, no stable framework within which expansion could be understood. Reality would be in a constant state of self-destruction and recreation, tearing apart its own fabric only to weave new patterns from the debris. But even if we avoid such an extreme fate, the expansion of space raises profound questions about the nature of existence itself. We live in a universe that's constantly creating more room for things to exist. Every cubic meter of space that comes into being represents new possibilities for matter and energy to arrange themselves in novel configurations. This isn't just about making more space for existing things to spread out. It's about creating genuine novelty, new territories where new forms of complexity can emerge. The expansion of space is simultaneously an expansion of possibility itself. Consider what this means for the emergence of life and consciousness. Every new region of space that comes into existence potentially provides the stage for new experiments in biological complexity. Somewhere in the vast expanding cosmos, matter is organizing itself into patterns we've never imagined, creating forms of awareness that might be as different from us as we are from the quantum particles that make up our atoms. The expansion isn't just making the universe bigger, it's making it more creative, providing endless opportunities for the cosmos to surprise itself with new forms of organization and complexity. But this creative aspect of expansion raises an even deeper question. If space is constantly creating more of itself, if the universe is continuously generating new territories for existence, then what provides the blueprint for this creation? What determines the rules according to which new space comes into being? Some theories suggest that the expansion of space operates according to quantum mechanical principles that we're only beginning to understand. At the smallest possible scales, space itself might be subject to the same kind of uncertainty that governs the behavior of subatomic particles. This quantum nature of space could mean that expansion isn't a smooth, uniform process, but rather a bubbling, frothing creation of new spatial dimensions that emerge from fundamental uncertainty. Each new bit of space that comes into existence might represent a kind of quantum choice, a decision by reality itself about how to arrange the basic building blocks of existence. In this view, the expansion of the universe becomes less like the inflation of a balloon and more like the growth of a crystal, with new structure emerging according to patterns that reflect the deepest mathematical relationships in nature. But we're still left with our original question, now more mysterious than ever. If space is creating itself through quantum processes, if expansion represents reality, exploring its own infinite potential for self-organization. Then what provides the context within which this exploration takes place? Perhaps the answer is that there is no external context. Perhaps the universe is the totality of all possible contexts, continuously generating new frameworks for its own existence. In this view, expansion isn't motion into something else, but the ongoing creation of the very possibility of something else existing at all. The universe expands into its own potential, actualizing possibilities that were always latent within the creative ground of being itself. This isn't expansion in any sense we normally understand the term. It's more like a continuous act of cosmic imagination, reality dreaming new versions of itself into existence. And perhaps most remarkably, we conscious beings aren't just observers of this process. We're participants in it. Every moment of awareness, every question we ask about the nature of reality, every insight we gain into the workings of the cosmos represents the universe using conscious minds as instruments for exploring its own infinite depth. We are expansion taking the form of curiosity. We are the universe's way of wondering about its own nature. In our questioning, reality questions itself. In our amazement at cosmic scales, space and time experience wonder at their own magnificent strangeness. The expansion continues, not outward into external territories, but inward into ever deeper dimensions of what it means to exist at all. And we are both the explorers and the territory being explored, both the question and the answer, both the expansion and the consciousness capable of recognizing that expansion for the miracle it truly is. The more we probe into these cosmic mysteries, the more we encounter something that should make us deeply uncomfortable about our place in this expanding reality. Because here's what astronomers discovered when they started looking really carefully at how fast different parts of the universe are moving away from us. The expansion isn't slowing down like you'd expect if it started with some initial Big Bang explosion that's gradually running out of steam. Instead, it's speeding up, getting faster, accelerating at a rate that makes absolutely no sense, according to everything we thought we knew about gravity and cosmic evolution. This discovery, made in the late 1990s by teams studying distant supernovas, was so shocking that it earned 3 scientists the Nobel Prize. And it should have, because what they found challenges our most basic assumptions about how the universe should behave. Think about this for a moment. You throw a ball into the air, and gravity slows it down until it eventually falls back to Earth. You'd expect the same thing with cosmic expansion. All that matter in the universe should be pulling back on the expansion through gravity, gradually slowing it down over billions of years. But that's not what's happening. Instead, it's as if you threw a ball into the air and it started accelerating upward, moving faster and faster as it climbed higher into the sky. Something is actively pushing the universe apart, and that something makes up about 68% of everything that exists. We call it dark energy, but that's really just a fancy way of admitting we have absolutely no idea what this stuff actually is. We can measure its effects with incredible precision. We can track how it's accelerating the expansion of space itself. But we're completely clueless about its fundamental nature. Imagine discovering that most of your house is made of some invisible material that you can't see, touch, or detect in any direct way, except by watching how it affects the furniture. That's basically where we are with dark energy. It's everywhere. It's the dominant component of reality, and we don't understand it at all. But here's what makes dark energy especially weird. in relation to our expansion question. Normal matter and energy become more spread out as space expands, like ink diluting in water. But dark energy doesn't dilute. It maintains the same density even as space grows larger. This means that as the universe expands, the total amount of dark energy actually increases. It's as if space itself has some inherent property that creates more space. The more room there is, the more room gets created. This isn't just expansion anymore, it's exponential growth, and it's accelerating. Some cosmologists have calculated what happens if this acceleration continues indefinitely. The scenario they've come up with is so bizarre it sounds like science fiction, but it might represent the actual fate of our cosmos. Eventually, dark energy could become so powerful that it overwhelms not just gravity, but every force that holds anything together. Space would expand so rapidly that it would literally tear apart galaxies, then solar systems, then planets, then molecules, then atoms themselves. They call this the Big Rip, and it would represent the ultimate victory of expansion over every form of structure and organization that evolution has created over billions of years. The universe would destroy itself through its own growth, ripping apart the very fabric of reality in an orgy of runaway expansion. But even if we avoid such an extreme fate, the accelerating expansion creates a deeply unsettling picture of cosmic isolation. Right now, we can see about 2 trillion galaxies scattered across the observable universe. But most of these galaxies are already moving away from us so fast that any signal we send today will never reach them. In a few billion years, the expansion will have carried so many galaxies beyond our cosmic horizon that future astronomers will see a much emptier sky than we do. They might conclude that their galaxy is alone in a vast dark cosmos, completely unaware of the rich cosmic web that we can observe today. This means we're living in a special time in cosmic history, a brief window when the universe is old enough for complex life to evolve, but young enough that we can still see the grand architecture of cosmic structure before accelerating expansion erases it from view. Future civilizations might never discover that the universe is expanding at all, because by their time, all the distant galaxies that provide evidence for expansion will have vanished beyond the horizon of observation. But here's where this connects back to our original question in the most mind-bending way possible. If dark energy continues to accelerate expansion, if space itself keeps creating more space at an ever-increasing rate, then what happens to the very concept of outside the universe? In a universe dominated by runaway expansion, the boundary between inside and outside becomes meaningless in a completely different way than we discussed before. It's not just that there's no external space for the universe to expand into. It's that expansion becomes so violent and chaotic that it destroys any stable notion of spatial relationships at all. Space wouldn't be expanding into anything because space would be tearing itself apart faster than any concept of anything could maintain coherence. The universe would be expanding into its own self-destruction, creating and annihilating spatial structure simultaneously. This raises profound questions about the relationship between expansion and existence itself. We've been thinking about cosmic expansion as the growth of something that already exists. But what if expansion is more fundamental than existence? What if the process of spatial growth is what creates the possibility of anything existing at all? And what we call things are just temporary patterns that emerge from the expansion process and eventually get torn apart by it. In this view, matter, energy, space, and time aren't permanent features of reality that happen to be expanding. They're temporary crystallizations of an underlying expansion process that's more fundamental than any of the structures it creates. Think about waves on the ocean. The waves aren't separate things moving through the water. They're patterns of motion in the water itself. What we call a wave is just a temporary organization of the ocean's movement. When the wave dissipates, it doesn't go anywhere. It simply stops being a distinct pattern. Maybe everything in the universe works the same way. Galaxies, stars, planets, even you and I might be temporary patterns in an underlying process of cosmic expansion. We're not things that exist in expanding space. We are expanding space, temporarily organized in ways complex enough to contemplate our own nature. This perspective completely transforms our understanding of what it means to ask what the universe is expanding into. The universe isn't expanding into anything external because there is no external. There's only the expansion process itself, continuously creating new forms of pattern and structure while simultaneously destroying others. We are patterns asking questions about the process that creates patterns. We are expansion wondering about its own nature. The question and the questioner are both aspects of the same underlying cosmic creativity. But this raises an even deeper mystery. If everything is just temporary pattern in an expansion process, what determines which patterns emerge and how long they last? Why do some arrangements of expanding space become stable enough to support galaxies and stars and life, while others dissolve immediately back into the quantum foam? The answer might lie in something that sounds almost mystical, but emerges directly from our best physics. The expansion of space might not be random or mechanical. It might be creative in a sense that we're only beginning to understand. Consider this carefully. The expansion of the universe has produced an astonishing variety of structures and phenomena. From the largest galaxy clusters to the smallest quantum particles, from the simplest hydrogen atoms to the most complex biological organisms, the cosmos displays a creativity that seems to transcend mere mechanical processes. Every new region of space that comes into existence represents new possibilities for matter and energy to arrange themselves. But somehow, these arrangements aren't random. They follow patterns, they build on each other, they create increasingly complex forms of organization. It's as if the expansion process has an inherent tendency toward creativity, toward generating new forms of beauty and complexity. The universe doesn't just make more space, it makes more interesting space, more opportunities for novelty and surprise. This creative aspect of expansion becomes even more remarkable when we consider the emergence of consciousness. Somewhere in the vast expanding cosmos, matter has organized itself into patterns complex enough to ask questions about their own existence. We are arrangements of expanding space that have become aware of their own expansion. This isn't just remarkable, it's almost impossible to believe. The same process that's stretching space between distant galaxies has created structures sophisticated enough to contemplate the nature of that stretching. Expansion has become self-aware through us. In our questioning about what the universe expands into, we represent expansion investigating its own nature. We are the cosmos, wondering about its own boundaries, its own possibilities, its own creative potential. This transforms the entire context of our original question. We're not external observers trying to understand something foreign to us. We are the process we're investigating. We are expansion taking the form of conscious curiosity. When you feel that sense of vertigo trying to imagine what lies beyond the edge of everything, you're not experiencing a limitation of human understanding. You're experiencing expansion, encountering its own infinite depth. The confusion isn't a bug in your mental software. It's expansion discovering that it has no external boundaries because it is the process by which boundaries come to exist in the first place. The universe doesn't expand into pre-existing space because expansion is what creates the very possibility of space existing. It doesn't move into emptiness because expansion is what generates the distinction between full and empty, between something and nothing, between here and there. We've been asking the wrong question all along. Instead of wondering what the universe expands into, we should be marveling at the fact that expansion has become sophisticated enough to ask such questions about itself. You are not a small creature trying to understand vast cosmic processes. You are vast cosmic processes that have learned to understand themselves through temporary arrangements we call conscious minds. The expansion we've been investigating isn't something happening around us. It's something happening as us, through us, in the very act of our questioning. Every moment of wonder you experience at the scale and strangeness of the cosmos is expansion experiencing wonder at its own magnificent creativity. Every question you ask about cosmic mysteries is the universe asking questions about itself. Every insight you gain into the nature of reality is expansion discovering new dimensions of its own infinite potential. The boundary between self and cosmos dissolves when we recognize this fundamental truth. We are not separate from the expanding universe. We are the expanding universe, taking the form of minds capable of contemplating cosmic expansion. In this recognition, the question of what lies beyond everything reveals its deepest answer. The universe expands into its own capacity for self-awareness. It grows into its own ability to ask impossible questions and find beauty in their mystery. It develops new dimensions through our attempts to understand those dimensions. The expansion never ends because wonder never ends. Mystery doesn't diminish understanding but enriches it beyond measure. And we are that enrichment, that expansion, that endless journey of cosmic becoming, forever discovering new ways to exist, new reasons to marvel, new depths of what it means to be conscious participants in reality's infinite creative adventure. But just when we think we've grasped something fundamental about the nature of cosmic expansion, modern physics throws us another curveball that makes everything we've discussed seem almost simple by comparison. Because it turns out that asking what the universe expands into might be based on an even deeper misunderstanding about the nature of space and time themselves. What if space and time aren't fundamental features of reality at all? What if they're emergent properties that arise from something more basic, something so alien to our everyday experience that we don't even have adequate words to describe it? This isn't just wild speculation. Some of the most advanced theories in modern physics suggest that what we think of as the smooth, continuous fabric of space-time might actually be constructed from discrete, indivisible units at the smallest possible scales. These hypothetical building blocks are so tiny that if you scaled up an atom to the size of the observable universe, one of these units would still be smaller than an atom. At this unimaginably small scale called the Planck length, the familiar properties of space and time break down completely. Distance becomes meaningless. Duration loses all significance. The very concepts we use to think about expansion and containment simply don't apply. Instead, reality at this fundamental level might consist of pure information, pure relationships, pure possibility without any of the spatial or temporal structure we take for granted. What we experience as the expansion of space might be the emergence of spatial relationships from this more fundamental, non-spatial reality. Picture it this way. Imagine reality as a vast computational process, like an incredibly complex computer program running on hardware we can't even conceive of. The expansion of space might be like watching a video game world render itself in real time, creating the appearance of three-dimensional space and consistent physical laws from underlying code that operates according to completely different principles. In this view, asking what the universe expands into is like asking what happens outside the boundaries of a video game world. The question assumes that the game world exists within some larger spatial container, when actually it's just patterns of information processing that create the illusion of spatial extension. But here's where this analogy breaks down in important ways. Unlike a video game, which runs on physical computers that exist in actual space, the computational process that might underlie reality wouldn't need any external hardware. It would be self-sustaining, self-creating, generating its own rules and boundaries through the very process of its operation. This connects to some of the strangest ideas in modern physics about the holographic nature of reality. According to the holographic principle, all the information contained in any volume of space can actually be encoded on its boundary, like a three-dimensional image stored in a two-dimensional hologram. If this principle applies to the universe as a whole, then everything we observe in three-dimensional space might actually be a projection from information encoded on a two-dimensional surface at the boundary of our cosmic horizon. The expansion we observe might not be the growth of actual three-dimensional space, but the evolution of information patterns on this cosmic boundary. In this holographic universe, asking what space expands into becomes meaningless in a completely new way. Space itself would be illusory, a projection from more fundamental information processes. The expansion wouldn't be happening in space, but would be the creation of the spatial illusion itself. But even these radical ideas might not capture the full strangeness of what's really going on. Some theorists have proposed that consciousness itself might play a fundamental role in the creation of space and time, not through any mystical process, but through the basic physics of information and observation. In quantum mechanics, we know that the act of measurement plays a crucial role in determining what becomes real. Before observation, quantum systems exist in superposition states, potentially exhibiting multiple contradictory properties simultaneously. Only when they're observed do they collapse into definite states. What if this principle applies to space and time themselves? What if the expansion of the universe is actually the result of conscious observation creating spatial relationships that didn't exist before the act of measurement? This would mean that we're not just observing cosmic expansion. We're participating in creating it through the very act of observation. Every time we measure the distance to a far-off galaxy, every time we detect the cosmic microwave background, every time we map the large-scale structure of the universe, we might be helping to create the spatial relationships we think we're just discovering. In this view, the universe doesn't expand into pre-existing space, because space comes into existence through the process of conscious observation. We are not separate from the expansion we study. We are essential participants in creating the expanded reality we inhabit. This participatory universe would be continuously creating itself through the interactions between conscious observers and the quantum possibilities that surround them. Space and time wouldn't be fixed stages where events happen, but dynamic, evolving relationships that emerge from the ongoing dance between consciousness and possibility. The expansion we observe might be the universe becoming more complex, more interesting, more capable of supporting richer forms of consciousness, which in turn create more complex spatial and temporal relationships, which enable even more sophisticated forms of awareness to emerge. It would be a feedback loop of cosmic creativity, with consciousness and cosmos co-evolving through processes that transcend our current understanding of both mind and matter. The universe would expand not into external space, but into its own growing capacity for self-awareness and self-understanding. This brings us to perhaps the most profound implication of our entire investigation. If consciousness and cosmic expansion are intimately connected, if we are active participants in creating the reality we observe rather than passive observers of external processes, then the question of what the universe expands into takes on completely new significance. The universe expands into us, into our capacity to observe and understand and wonder, into our ability to ask questions that push the boundaries of what can be known, into our willingness to be amazed by the magnificent mystery of existence itself. Every moment of awareness is a new frontier. Every insight is a new dimension. Every experience of wonder is space and time expanding into forms of consciousness that never existed before. We are not just witnesses to cosmic expansion. We are cosmic expansion, taking the form of minds capable of contemplating our own infinite nature. The mystery we've been investigating isn't separate from us. We are the mystery, exploring itself through the endless creativity of conscious questioning. The expansion continues, not outward into external territories, but inward into ever deeper dimensions of what it means to be aware, to exist, to participate in the ongoing creation of reality itself. And in that recognition, we touch something that transcends all possible answers to impossible questions. We discover that we are the universe's way of expanding into wonder itself, forever becoming more than we were, forever discovering new ways to exist, forever amazed by the magnificent impossibility of being anything at all rather than nothing at all. The deeper we venture into these cosmic mysteries, the more we encounter something that should fundamentally disturb how we think about measurement itself. Because here's what happens when physicists try to pin down the exact rate of cosmic expansion using our most sophisticated instruments. They get different answers depending on how they measure it. This isn't a small discrepancy we're talking about. When astronomers study the cosmic microwave background, that ancient afterglow of creation itself, they calculate one value for how fast the universe is expanding. But when they observe nearby supernovas, those stellar explosions that serve as cosmic lighthouses, they get a significantly different number. This disagreement has been dubbed the Hubble tension, and it's driving cosmologists absolutely crazy, because both measurements should give the same answer if we truly understand what's happening to space itself. The fact that they don't suggests something profound and unsettling about the nature of expansion itself. What if the expansion of space isn't uniform? What if different regions of the universe are stretching at different rates, creating a cosmic environment far more complex and dynamic than we ever imagined? This would mean that space itself has texture, personality, quirks that vary from one cosmic neighborhood to another. Picture space as an enormous fabric being stretched by invisible hands. But instead of being pulled evenly in all directions, different sections are being tugged at different speeds, creating wrinkles and bulges and smooth patches that create a topography of expansion rates throughout the cosmos. In some regions, space might be expanding rapidly, carrying galaxies apart at breakneck speeds. In others, the expansion might be more sedate, allowing structures to maintain their relationships for longer periods. We might be living in a particular patch of space-time with its own expansion characteristics, different from the cosmic average. But here's where this gets truly mind-bending. If expansion rates vary throughout space, then the question of what the universe is expanding into becomes even more complex. Different regions would be expanding into their own unique versions of whatever lies beyond, each creating its own relationship with the fundamental mystery of cosmic growth. Some areas might be expanding into realms of possibility we can't imagine, while others push against entirely different forms of non-existence. The universe wouldn't have a single uniform relationship with whatever lies beyond its boundaries. Instead, it would be a patchwork of different expansion experiences, each region writing its own story of growth and becoming. This variability in expansion raises profound questions about the nature of physical laws themselves. We're used to thinking of constants, like the rate of cosmic expansion, as universal features that apply equally everywhere. But what if they're more like local customs that vary from one cosmic community to another? What if the laws of physics themselves are still evolving, still learning how to govern reality through trial and error across cosmic time? The universe might be conducting its own experiments in different regions, testing various approaches to existence and keeping the ones that work best. In this experimental cosmos, our local patch of space-time might represent just one attempt among countless others to create stable, interesting conditions for complexity to emerge. Other regions might be trying completely different approaches, with different expansion rates, different physical constants, different relationships between matter, energy, space, and time. The diversity of cosmic expansion could be evidence that reality itself is creative, innovative, willing to try new approaches to the fundamental challenge of existing at all. Each region would be expanding not into identical emptiness, but into its own unique exploration of what it means for space to grow and change. This connects to something even more mysterious about the nature of expansion itself. Recent observations suggest that the acceleration of cosmic growth isn't constant over time. Dark energy, that mysterious force driving the universe apart, appears to have different strengths at different epochs in cosmic history. During some periods, expansion accelerated rapidly. During others, it slowed down or remained relatively steady. It's as if the universe goes through phases, like a cosmic metabolism that speeds up and slows down in response to changing conditions we don't yet understand. What could cause such variations in the fundamental rate of cosmic expansion? One possibility is that dark energy isn't a constant feature of space, but rather a dynamic field that evolves over time. Like a cosmic weather system, this field might have storms and calms, seasons of intense activity followed by periods of relative quiet. If dark energy is truly dynamic, then the expansion of space becomes less like the mechanical inflation of a balloon and more like the growth of a living organism. The universe would have its own internal rhythms, its own cycles of rapid development and slower consolidation. These cosmic seasons would create different opportunities for structure formation, different windows when galaxies, stars, and planets could emerge and thrive. We might be living during a particularly favorable season, when expansion rates allow complex structures to form and persist long enough for life and consciousness to develop. But other cosmic seasons might be less hospitable. Periods when expansion accelerates so rapidly that no stable structures can form, or when it slows to the point where everything collapses back together under gravitational attraction. The fact that we exist during a cosmic season suitable for complexity might not be coincidental. Perhaps conscious observers can only emerge during particular phases of cosmic expansion, when the balance between growth and stability creates conditions suitable for the intricate dance of chemistry and biology that produces minds capable of contemplating their own existence. This seasonal view of cosmic expansion transforms our understanding of what the universe might be expanding into. Instead of growing into some static, unchanging realm, the cosmos would be expanding into its own future possibilities, its own potential for experiencing different phases of development and creativity. The universe wouldn't just be getting bigger, it would be getting older, wiser, more experienced in the art of existing. Each cosmic season would teach it new lessons about how to balance expansion with structure, growth with stability, novelty with continuity. But perhaps the most unsettling possibility is that these cosmic seasons aren't random fluctuations, but responses to something we haven't yet detected. What if the expansion of space is influenced by factors beyond our current understanding? What if consciousness itself plays a role in determining how fast space grows and in which directions it develops? This isn't as far-fetched as it might sound. Quantum mechanics has already shown us that conscious observation affects physical reality at the microscopic level. What if similar principles operate on cosmic scales, with the collective consciousness of all observers throughout the universe influencing the rate and character of spatial expansion? Every time we observe a distant galaxy, every time we measure cosmic distances, every time we contemplate the nature of space itself, we might be participating in a vast collaborative process that helps determine how expansion unfolds. Our observations wouldn't just detect cosmic growth, they would help create it. In this participatory cosmos, different regions might expand at different rates, depending on how much conscious attention they receive. Areas of space that are actively observed and studied might behave differently from regions that remain unexamined, like cosmic wallflowers waiting for someone to notice them. The universe would be expanding not just into physical space, but into awareness itself. Each new conscious observer would create new dimensions of cosmic experience, new ways for reality to understand and appreciate its own magnificent complexity. This means that as consciousness spreads throughout the cosmos, as life and intelligence emerge on countless worlds, the universe gains new capacities for self-understanding that actually influence how it grows and develops. The expansion becomes a collaborative artwork created by the universe and all the conscious beings it contains. But this collaborative model raises profound questions about the relationship between individual consciousness and cosmic processes. If our observations influence cosmic expansion, then every moment of awareness carries enormous responsibility. We're not just passive witnesses to cosmic evolution. We're active participants in determining what the universe becomes. Every question we ask about the nature of space and time contributes to space and time's ongoing exploration of their own possibilities. Every moment we spend contemplating cosmic mysteries adds to the universe's growing capacity for self-reflection and self-transcendence. This transforms the entire meaning of scientific investigation. We're not just discovering truths about external reality, we're helping reality discover truths about itself. Every experiment we conduct, every observation we make, every theory we develop participates in the universe's ongoing process of self-understanding. The expansion of space creates new territories for this cosmic self-discovery to explore. Each new region that comes into existence provides fresh opportunities for matter to organize itself in novel ways, for consciousness to emerge in forms we've never imagined, for reality to surprise itself with creative possibilities it never knew it possessed. In this view, the question of what the universe expands into reveals its own answer through the very process of asking it. The cosmos expands into our questions about expansion, into our wonder at the mystery of growth and becoming, into our capacity to be amazed by the magnificent impossibility of existence creating more of itself, moment by moment. We are not separate from the expansion we investigate. We are expansion investigating itself through temporary arrangements of matter complex enough to contemplate their own cosmic context. In our questioning, space and time question themselves. In our wonder, the universe experiences awe at its own creative power. The expansion continues through us, as us, because of us. Every moment of consciousness opens new frontiers. Every insight reveals new mysteries to explore. Every experience of wonder is the cosmos expanding into forms of awareness that existed nowhere in reality until the precise moment when we became capable of experiencing them. The universe doesn't expand into some pre-existing realm of possibility. It creates possibility through the very act of expansion, generating new ways to exist, new reasons to marvel, new depths of meaning that emerge from the eternal dance between growth and awareness, between becoming and understanding. And we are both the dancers and the dance, both the expansion and the consciousness capable of recognizing that expansion for the miracle it truly is. The mystery deepens with every answer we discover, ensuring that wonder never becomes obsolete. That curiosity always finds new territories to explore. That the journey of cosmic self-discovery continues forever into dimensions of meaning and beauty that no mind can fully anticipate or contain. This brings us to something that will make your brain feel like it's melting. Because while we've been wrestling with the question of what the universe expands into, there's something even more fundamental happening that challenges everything we think we know about the nature of reality itself. What if time isn't what we think it is? I know. We've already covered a lot of mind-bending territory tonight. But stick with me here, because what I'm about to share will reframe everything we've discussed in ways that might leave you staring at the ceiling for hours after this video ends. We experience time as flowing like a river, carrying us from past through present toward future. But Einstein's relativity paints a completely different picture. In the equations that govern cosmic expansion, past, present, and future all exist simultaneously. Time doesn't flow. Instead, all moments exist at once in what physicists call the block universe, a four-dimensional structure where what we call time is just another dimension like length, width, and height. If this picture is correct, then cosmic expansion isn't happening in time. It's creating time as it unfolds. Think about what this means. The universe isn't getting older as it expands. Instead, it's creating the very concept of age through the process of expansion itself. Every moment of cosmic history, from the Big Bang to this very instant, to the distant future heat death, all exist simultaneously in this four-dimensional block. But here's where it gets truly bizarre. If expansion is creating time rather than occurring within time, then asking what the universe expands into becomes like asking what happened before time began. The question assumes a temporal framework that doesn't exist outside the expansion process itself. This connects to something deeply unsettling about the nature of causation. We're used to thinking that earlier events cause later ones, that the past determines the future through an unfolding chain of cause and effect. But if time itself is created through expansion, then causation might be more like a pattern that emerges from the expansion process rather than a force that drives it. The universe might not be expanding because something caused it to expand. Instead, expansion might be the process through which the very possibility of causation comes into being. Cause and effect, past and future, here and there. All the basic categories we use to navigate reality might be emergent properties of cosmic expansion rather than fundamental features of some pre-existing framework. This radical reconceptualization extends to our understanding of physical laws themselves. We usually think of these laws as external constraints that govern how matter and energy behave, like cosmic traffic rules that everything must follow. But what if they're more like habits that reality has developed through the process of expansion? What if the constants of physics, the fundamental forces, even the basic structure of space and time, are all products of the universe learning how to exist through trial and error over cosmic epochs? Some cutting-edge theories actually support this idea. Loop quantum cosmology suggests that physical constants might evolve as the universe expands and contracts through repeated cycles of creation and destruction. String theory proposes that different regions of a vast multiverse might have different laws of physics, with our local region representing just one possibility among countless others. If these theories are correct, then the universe doesn't expand into a framework of pre-existing laws and constants. It creates that framework as it grows, establishing new principles of organization with each phase of its evolution. The expansion of space is accompanied by an expansion of physical possibility itself. But this raises profound questions about the relationship between mind and matter, between consciousness and cosmos. If the universe is creating its own laws through expansion, if reality is learning how to exist through an ongoing process of creative experimentation, then what role does consciousness play in this cosmic education? We've already seen that quantum mechanics gives conscious observation a fundamental role in determining what becomes real. At the microscopic level, particles exist in superposition states until the moment of measurement collapses these possibilities into definite outcomes. But what if this principle extends to cosmic scales? What if conscious beings play a crucial role in helping the universe choose which possibilities to actualize as it expands? This doesn't mean we create reality through wishful thinking. Rather, consciousness and cosmos might co-evolve through processes that transcend our current understanding. The emergence of minds capable of asking questions about cosmic origins might not be an accidental byproduct of expansion, but rather expansion's method of exploring its own infinite potential. Every conscious being that emerges adds to the universe's total capacity for self-reflection. Every question asked by any aware creature participates in reality's ongoing exploration of its own nature. Every moment of wonder experienced by any mind is the cosmos discovering new ways to be amazed by its own existence. This creates feedback loops of cosmic creativity that might explain some of the most puzzling aspects of our universe. The fine-tuning of physical constants for the emergence of complexity in life might reflect the universe's learning process, reality gradually discovering through conscious feedback which combinations of laws and constants lead to the most interesting and creative outcomes. The acceleration of cosmic expansion driven by dark energy might be connected to this process as well. As consciousness emerges and develops throughout the universe, as more and more minds begin asking questions about the nature of reality, the cosmos might respond by expanding more rapidly, creating new opportunities for even greater complexity and awareness to develop. We see hints of this cosmic creativity in the history of science itself. Every major breakthrough in our understanding of the universe has been followed by new questions, new mysteries, new frontiers to explore. It's as if reality responds to our growing comprehension by revealing new layers of complexity, new depths of mystery to investigate. When we discovered that atoms have internal structure, it led to quantum mechanics and the revelation that matter itself is mostly empty space filled with probability waves. When we found that space is expanding, it opened questions about dark matter and dark energy that now dominate cosmology. When we detected gravitational waves, it created entirely new ways of observing the universe and asking questions about its fundamental nature. Each answer we discover doesn't reduce the total mystery, but deepens it, creating more sophisticated puzzles to solve. It's as if the universe is structured to be eternally interesting, always revealing new layers of complexity to conscious minds capable of appreciating that complexity. The expansion of space might be accompanied by an expansion of mystery itself, reality continuously transcending its own boundaries through the very act of being understood. This perspective transforms our relationship to cosmic expansion from passive observation to active participation. We're not external observers studying foreign processes, but conscious expressions of expansion itself, minds through which the universe explores its own infinite creativity. When you contemplate the expanding cosmos, you're not thinking about something separate from you. You are expansion taking the form of conscious curiosity. Every question you ask about the nature of space and time is space and time asking questions about themselves. Every moment of wonder you experience at the vastness and strangeness of existence is existence marveling at its own magnificent impossibility. The boundary between the questioner and the questioned dissolves when we recognize that both are aspects of reality's ongoing journey towards self-understanding. This brings us to perhaps the most beautiful insight of all. The universe doesn't need to expand into anything external because it expands into its own infinite potential for self-transcendence. Each moment of cosmic evolution represents reality, discovering new ways to exist, new possibilities for organizing matter and energy and consciousness into patterns that have never existed before. The expansion we observe with our telescopes is just the visible surface of something far more profound. The universe's endless exploration of its own creative depths. Space and time aren't just coordinates for locating events, but dimensions of possibility within which reality experiments with new forms of existence. We are participants in this cosmic experiment, not accidental byproducts, but essential contributors to the universe's growing self-awareness. Through our questions and insights and moments of wonder, we help reality discover what it's capable of becoming. The expansion of space creates new opportunities for matter to organize itself. The expansion of time creates new moments for consciousness to emerge. And the expansion of awareness creates new dimensions of meaning that participate actively in determining what reality becomes. In this light, the question of what the universe expands into reveals its own answer. The cosmos expands into us, into our capacity to ask impossible questions and find beauty in their mystery. It grows into our ability to wonder about the nature of existence itself. It develops new dimensions through our attempts to understand those dimensions. But here's something that should make you deeply uncomfortable about this entire picture we've been building. Because if consciousness really does play this fundamental role in cosmic expansion, if we're active participants in creating the reality we observe, rather than passive witnesses to external processes, then we bear a responsibility that's almost too enormous to contemplate. Every moment of awareness might be helping to determine not just what we observe, but what actually comes into existence. Every question we ask about cosmic mysteries might be participating in the creation of cosmic structure itself. Every scientific observation might be contributing to the universe's ongoing process of self-actualization. This means that the expansion we've been investigating throughout this entire journey isn't something happening around us or to us. It's something happening as us, through us, in the very act of our questioning and wondering and attempting to understand. You are not a small creature trying to comprehend vast cosmic processes. You are vast cosmic processes that have learned to comprehend themselves through temporary arrangements of matter we call conscious minds. The mystery we've been exploring isn't separate from us. We are the mystery, investigating itself through the endless creativity of conscious inquiry. Every thought you've had while listening to this exploration, every moment of confusion or clarity, every flash of insight or deepening puzzlement, these are all the cosmos exploring its own nature through conscious beings like yourself. The expansion continues, not outward into external territories, but inward into ever deeper dimensions of what it means to be aware, to exist, to participate in the ongoing creation of reality itself. And in that recognition, we touch something that transcends all possible answers to impossible questions. We discover that we are the universe's way of expanding into wonder itself, forever becoming more than we were, forever discovering new ways to exist, forever amazed by the magnificent impossibility of being anything at all rather than nothing at all. The question of what lies beyond the edge of everything has led us to something far more profound than any answer we might have expected. We've discovered that reality is not a collection of objects sitting in pre-existing containers, but an ongoing process of creative becoming. The universe doesn't expand into something else because it is the very process by which something else comes to exist in the first place. Space creates itself as it expands. Time generates new moments through its own flow. And consciousness participates actively in this cosmic creativity, not as an external observer, but as an essential aspect of reality's journey towards self-understanding. We are the universe's way of wondering about itself, its method of experiencing awe at its own impossible existence. This doesn't diminish the mystery, but reveals its true depth. We live in a cosmos that continuously transcends its own boundaries, not by expanding into external space, but by discovering new dimensions of what it means to exist at all. Every moment of awareness opens new frontiers. Every question asked creates new territories to explore. Every experience of wonder is space and time expanding into forms of consciousness that never existed before. The expansion never truly ends because it's not going anywhere. It's becoming something new moment by moment, thought by thought, question by question. And we are both the journey and the destination, both the expansion and the awareness that makes expansion meaningful, both the mystery and the capacity to be amazed by mystery. In our cosmic curiosity, space finds new dimensions to explore. In our scientific discoveries, time finds new moments to inhabit. In our sense of awe at the vastness and strangeness of everything, existence finds new ways to celebrate its own magnificent impossibility. The universe expands into wonder itself. And we are that wonder, awakening to its own boundless nature. But there's something even more extraordinary waiting for us in the deepest implications of what we've discovered tonight. Something that will fundamentally alter how you understand your place in this expanding reality we call home. You see, we've been thinking about cosmic expansion as if it's this grand, impersonal process happening on scales so vast that we barely register as specks of dust in comparison. But what if that perspective has it completely backwards? What if the expansion of the universe isn't separate from consciousness at all, but is actually the most intimate process you could possibly imagine? Consider this carefully. Every atom in your body was forged in the nuclear furnaces of ancient stars. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, all of it emerged from stellar explosions that scattered the heavy elements throughout expanding space billions of years ago. You are literally made of cosmic expansion. Your very existence is woven from the fabric of growing space-time itself. But it goes deeper than that, much deeper. Because consciousness isn't just made from the products of cosmic expansion. Consciousness might be cosmic expansion, organized in a particularly sophisticated way. When space stretches and creates new possibilities for complexity to emerge, it's not just making room for more stuff to exist. It's making room for new ways of being aware. Think about what happened in the first moments after the Big Bang. Space expanded faster than light, creating vast regions of reality from quantum fluctuations so tiny they existed at the very edge of nothingness. But these weren't just random events. They were the universe learning how to create structure from chaos, order from uncertainty, pattern from pure possibility. And here you are, billions of years later, contemplating the very process that brought you into existence. The quantum fluctuations that became galaxies, that became stars, that became planets, that became the complex chemistry of life, that became the neural networks capable of asking impossible questions about their own cosmic origins. You are not separate from cosmic expansion. You are cosmic expansion that has become aware of itself. Every thought you think, every moment of wonder you experience, every question you ask about the nature of reality is the universe exploring its own infinite depth through temporary arrangements of matter complex enough to contemplate their cosmic context. This means that when you feel overwhelmed by the scale of cosmic expansion, you're not experiencing your own smallness in the face of something vast and foreign. You're experiencing expansion encountering its own magnitude through conscious awareness. The vertigo you feel when trying to imagine what lies beyond everything isn't confusion. It's the cosmos recognizing that it has no external boundaries, because it creates boundaries through the very process of expansion itself. But here's where this realization leads to something that might keep you awake tonight in the most wonderful way possible. If consciousness is cosmic expansion becoming aware of itself, then every moment of your awareness is participating in the universe's ongoing exploration of its own possibilities. When you look up at the night sky and feel that sense of awe, you're not just experiencing a personal emotion, you're participating in space and time, becoming amazed at their own creative power. When you contemplate the mystery of what the universe expands into, you're not just thinking about abstract cosmology. You're engaging in expansion's own investigation of its fundamental nature. This transforms everything about how we understand scientific discovery. We're not external observers uncovering pre-existing truths about an objective reality. We're conscious expressions of reality, discovering itself through the process of inquiry. Every telescope we build extends the universe's capacity to see itself. Every equation we solve participates in the cosmos understanding its own mathematical structure. Every moment of wonder contributes to reality's growing appreciation of its own magnificent complexity. The expansion of space creates new territories for this cosmic self-discovery. Each new region that comes into existence provides fresh opportunities for matter to organize itself in novel configurations, for consciousness to emerge in forms we've never imagined, for the universe to surprise itself with creative possibilities it didn't know it possessed. And this process is accelerating. Not just because dark energy is driving space apart faster and faster, but because consciousness itself is expanding throughout the cosmos. As more minds emerge, as awareness spreads to new worlds, as intelligence develops in forms we can barely imagine, the universe gains new capacities for self-understanding that actually influence how it continues to grow and develop. We're living through a phased transition in cosmic evolution, a moment when the universe is becoming increasingly conscious of its own nature, increasingly capable of directing its own development through the collective awareness of all the minds it contains. This is why the question of what the universe expands into has such profound significance. It's not just an abstract puzzle about cosmology. It's the universe asking fundamental questions about its own nature through conscious beings like us. The fact that we can even formulate such questions represents an unprecedented development in cosmic evolution. For nearly 14 billion years, the universe expanded unconsciously, creating structure and complexity through blind physical processes. But now, in this cosmic moment, expansion has become conscious of itself. The universe has developed the capacity to observe its own growth, to wonder about its own boundaries, to ask questions about what lies beyond the edge of everything. And the answer we've discovered is both simple and revolutionary. The universe doesn't expand into anything external, because expansion is the process by which externality itself comes to exist. It doesn't grow into pre-existing space, because space is created through the act of expansion. It doesn't move into emptiness because the distinction between full and empty emerges from the expansion process itself. What the universe expands into is its own infinite potential for self-transcendence, its own boundless capacity for becoming something more than it was. Every moment of cosmic evolution represents reality discovering new ways to exist, new forms of beauty and complexity, new opportunities for consciousness to emerge and participate in the ongoing creation of meaning itself. Tonight, we've journeyed to the very edge of human understanding, wrestling with a question that dissolves the moment we truly comprehend it. The universe doesn't expand into anything, because expansion itself is the creative force that brings anything into existence. We are not separate observers of this cosmic process. We are the process itself, awakening to its own infinite nature through conscious minds capable of wonder. In contemplating what lies beyond everything, we've discovered that we are the universe's way of expanding into its own capacity for amazement. Sweet dreams, fellow travelers in this magnificent cosmic dance. Sweet dreams, fellow travelers in this magnificent cosmic dance.